Science Uncut, presented by the Volkswagen Foundation.
Thank you very much for the invitation. And Dr. Kohl mentioned the play by the Swiss author Dürrenmatt, where the protagonist, physicist, actually commits himself into a mental asylum. I just hope that none of us here goes with or without our own volition will end up in an asylum. I think it's a little bit, I just saw this play. It is a somewhat dated play, but I think it is probably appropriate, but I think it is somewhat fear-mongering. And that brings me to my talk. I like to always show influenza in terms of its pandemic of 1918, where we have the life expectancy in the US starting 1900, going all the way up to 2000. And there is a very nice, almost straight curve up. Someone born around 1900 had a life expectancy of only somewhat above 45 years of age. And a baby girl born today is way over 80 years. However, there is a stark dip in the life expectancy curve of the 1918-1919 pandemic. This is an 11-year dip of the life expectancy, and in the US we had about 750,000 deaths, and we saw already worldwide the estimates are between 50 and 100 million deaths. I should also point out that in terms of the US military costs and deaths, during World War I, more people, more US military died of the influenza rather than military action. However, we have to put this into perspective. And if I take, again, some data from the US, just New York City, if we look in the last century, not the 20th, but the one before, 19th century, then in this case now we have death on the y-axis. So the 1918 pandemic is a little sort of blip here, but much more important, and you probably can't read this, this is the conquest of pestilence in New York City, and we have cholera, we have smallpox, we have yellow fever. All of this is much, much higher than this dip or this peak in terms of influenza. And if we sort of look again at a comparison of different death numbers, and these are Global Health Council, and again, one can quibble about the numbers as they are here in terms of World War I, World War II, but it is very important. Smallpox death, and this is mostly the beginning of the 20th century, the numbers of deaths are much, much higher. I will also show, this is from the Department of Defense in the US, and they have, in this case, it's an alphabetical order of selected emerging zoonotic viral infections, and again, Dr. Fouchier has already alluded to this, so it starts here with Ebola, but this is only because of the alphabetical order. And we go down to Eastern equine encephalitis virus, hantavirus, HIV, flu, Nipah, SARS, West Nile encephalitis virus. And on this list of the Department of Defense, we don't even see, for example, a dengue virus. So the first point I really want to make is that nature does it better. Coming back to influenza, we heard already we have the 1918 pandemic, and this shows here, this is an H1N1 virus, and the first influenza viruses of which we have samples, there were no refrigerators really until the late 40s, comes from 1933, 1934, and then we had this H1N1 virus constantly changing. We heard already H2N2 appearing in 1957, only stayed for 11 years. H3 since 1968, and it is still with us, and then we had a reemergence in 1977 of H1N1 viruses. And then very interestingly, we had the pandemic H1N1 coming, which is different from the seasonal H1N1, and we believe that actually the extinction of the seasonal H1N1 has to do with the pandemic H1N1 by inducing stalk-specific antibodies in terms of eliminating this earlier one. And I believe actually that the sort of increase in these very broadly protecting antibodies against the stalk will actually induce the extinction of this pandemic H1N1 pretty soon. I would predict it will only be here for, again, 2 or 3 years. And then we certainly don't know what will happen in terms of the new pandemic strains. I should also want to mention that we have these different hemagglutinins. We have already heard there are different serotypes. In humans, so far, we only had H1, H2, and H3. And some of us, specifically myself, I believe that it might be very difficult for these other H5s, H7s, etc., come into humans and cause a pandemic. I always have submitted that these cases, and I will talk a little bit more about H5 and H7 again, are really only the result when large quantities of this virus are inhaled. And if you have looked at Dr. Fouchier's data, in terms of the H7 and 9, he has to introduce large quantities of the virus into a ferret and actually to get a transmission. So I see the view in terms of influenza virus a little bit different than some of my colleagues. So we have only H1 here, we have only H2, H3 in the last basically 100 years, but there's even some evidence that there were viruses of the H3 type before H1N1, and then H1 again before 1889. Okay, now, if we talk again about these viruses which have been shown to infect humans, we have heard about some of them already. There were reports in China, Taiwan, etc., of these H10, H7, H6, etc., over the years. But in all of these cases, if we talk about H10, H7, these were, in my opinion, always avian viruses where animal handlers or people who were in close contact with these infected and diseased animals really actually contracted the disease. And then certainly the most important one of those is H5. But again, I believe that only when we inhale 10 to the 5, 10 to the 6, 10 to the 7 particles, actually a human disease can result from infections with these different viruses. Some of the problems which we have result from this technology of reverse genetics, and it looks like when we talk to people, sometimes this is a completely new technology. I would like to remind you that we have published a paper literally 25 years ago, quarter of a century, where we showed for the first time that we can rescue infectious influenza viruses by transfecting cells with RNAs derived from specific recombinant DNAs. So it's an RNA virus, influenza virus, and reverse genetics means in terms of changing this RNA virus, we have to go back into DNA first and then introduce that DNA into the virus. So this is really not a new technology, more than 25 years around, and so I think we should have that in mind as well when we discuss the dual use of research. I have published in PNAS in 2012 an article about H5N1, influenza viruses, facts, not fear, and I feel very strongly that the sort of conclusions which I made at that time are still valid today. And I want to go briefly through some of those. That I have questions about the relevance of the ferret system in terms of really believing that they can tell us they can tell us a lot, and I'm certainly for continuing these experiments, but that they are very limited and that they are not really as dangerous as many of our colleagues are fearing that they are. I also want to make a point about the case fatality, that indeed these numbers have to be looked at a grain of salt. You have probably all heard that H5N1, 60–70% case fatality ratios. Same, a little bit lower with H7N9, etc. I will also make a point that I don't think these experiments really lead us that H5N1 or other influenza viruses can be used really effectively with as biological weapons. And then certainly I feel very strongly about that we cannot prevent publication of those kinds of data. Okay, in terms of the first point, that the relevance of the ferret system is, I don't want to say questionable, but clearly I think we have to look at this animal system as well as other animal systems and see what the limitations are. So I really question whether a virus which can be transmitted easily from one ferret, or in our case, for example, guinea pigs, really will acquire the ability to actually transmit better in humans, one. And two, at the same time, when we passage such a virus in ferrets, it loses a lot of its virulence, and this has been mentioned by Dr. Fouchier already. The way of making vaccines in the old days, with poliovirus, for example, is passaging it in a tissue culture system. Or smallpox, it was passaged probably in a cow, and then it becomes actually less virulent for humans. So I think this is a very important point, that a gain of function experiment at the same time has a loss of function for many other properties. And I would submit that passaging it in ferrets or in guinea pigs will actually result in a loss of, as we have heard already, in a virulence in the ferret, but certainly in a loss of virulence in humans. So I think we should really re-evaluate these kinds of animal experiments which we are doing. And I just want to mention the guinea pig system in terms of transmission. I read actually in a paper from 1919 that in Camp Cody, which is was a military camp, that they had actually to deal with all the human influenza at the time, but also they had some guinea pigs around. And part of this paper says, in connection with the experimental work, it is interesting to note that very soon after the epidemic of influenza, and this was 1919 in Camp Cody, reached this camp, our laboratory guinea pigs housed in a small building besides the laboratory began to die, and then later on they got a second batch of guinea pigs, and they also died. And so we used that and established a guinea pig transmission model, the same way we've heard about the ferret transmission model. And again, ferrets are not, mice are not men, ferrets are not female, guinea pigs are not humans, etc. So what we have, however, been able to do is, I think, quite interesting experiments in terms of looking at a human influenza virus, how it transmits from basically having one cage guinea pig in one guinea pig in a cage here, infect that guinea pig, and then ask how easy is it to infect guinea pigs, uninfected guinea pigs in neighboring cages, how easy it is to transmit it through the air. And there one can learn quite a lot of things. For example, here we have found that at low temperature, 5 degrees, and at low relative humidity, you can much easier transmit the virus as compared to high temperature and higher humidity. And this was done mostly work by Anis Lowen and John Steele in my laboratory. Having said that, I think we can learn a lot from these transmission models and from these animal models, but certainly in terms of humans, I think we should be cautious. Let's come back to H5N1. We have heard that this virus, certainly, if you are a chicken, as I always say, this is really bad news. However, I question whether this H5N1 virus is really as dangerous as it has been made out to. And particularly, if we look now at the case fatality ratio, and this is based upon numbers the WHO is reporting. And there we have, to the middle of this year, we had the total cases, and these are WHO numbers of 667, and the total death number of 393, and that's an enormously high case fatality ratio. However, the WHO only uses cases of hospitalized patients, have dead people coming in there, and then having it confirmed by PCR. We have shown by looking at the literature that actually a large number of people have probably infected. So we believe that these cases which the WHO reports are the result of massive amounts of virus being inhaled by people, but if one has a small dose, then one gets it, maybe aclinical, subclinical infections. And one can see in the literature, and we have published this in a meta-analysis in Science, that there is zero evidence of H5N1 influenza virus infections in humans. And I think the same has recently been shown for H7N9. Even if we have only 2%, 5% of the people having seen this, that means it's a large number of people who have been infected with H5, H7 viruses, but only those, in my opinion, who have inhaled, gotten a bolus of influenza, actually come down with really serious disease. So that's another point which I would like to make along the lines of facts, not fear. And again, after all of these events, the avian H5N1 virus does not efficiently transmit from human to human, and there are literally, in nature, many of these transmissions, or many of these infections have been reported. Now, if we look at these H7N9, we have similar cases here that the numbers are very high, but again, so in this case here, these are the CDC data from China, and one sees the dark blue is the cases alive, and the light blue are the diseased cases, and one can see here in terms of 2013 and 2014 these peaks. Now, living in New York, the most important publication in New York City, particularly for my dean, is the New York Times. And when he reads that there was a doomsday virus engineered, he gives me a call and says, "Peter, are you crazy what you are doing?" And then he reads that these experiments are more dangerous than smallpox. They talk about smallpox, that is how the United States and Russia contain samples of smallpox, which possess nowhere near the same danger of global devastation as these H5N1 viruses, which have been made in the laboratory. And so my dean obviously got quite upset about it and wanted to know what was going on. Unfortunately, 2 months later, the New York Times basically retracted this doomsday virus scenario and became a little bit more realistic, but the dean never called me back. But I still have my job. So I also feel very strongly that it is an anti-scientific, anti-intellectual, anti-scholastic, scholarly argument of not publishing data in terms of these kinds of experiments, because I really think they are not as dangerous as many of us make them out. And I've also published this in a sort of op-ed, not New York Times, but in this case, Nature. Okay, so to summarize so far, I really feel strongly that I think we should put into perspectives all of these animal systems, whether it's a ferret, whether it's the guinea pig, or the mouse even. I think these numbers of case fatality ratios, because they are really terrible. I mean, if I tell my wife I'm working with a virus which causes a case fatality of 60, 70%, she says I'm crazy. I don't think that's the case. This is large doses, and has nothing to do with the actual danger of these viruses. Could the data be used to generate a biological weapon? I really don't think so. I mean, I wouldn't know how to do it. I've worked with these viruses for many, many years. I'm quite familiar with reverse genetics. I really wouldn't know how to do it. And in terms of the publications, again, I feel very strongly we should really not try to clamp down on those kinds of government-down regulations, which are really, I think, quite difficult to stomach. And let me end here with this, that we have heard already that the US government is really cracking down on us. I find this is somewhat against the progress and against the kind of science which we would like to do. On the other hand, let me end up on a positive note. There are still agencies and foundations which allow one to work effectively. I want to mention briefly, we have been able to develop a new approach to make a universal influenza virus vaccine, where we basically have a vaccine which is, has a hemagglutinin with a stalk and a head, and then if we then boost with a different hemagglutinin which has the same stalk but a very different hemagglutinin head, and boost the second time again with a hemagglutinin which has a different head and the same stalk, the nomenclature is here, it's a chimeric hemagglutinin in terms of this head here, but the same 2014 neuraminidase, and this is work by Florian Kramer and Adolfo Garcia Sostre in my own laboratory. We are able to, in the animals, very well to induce a very cross-protective immune response against all different kinds of subtype influenza viruses and different strains. But again, mice are not men, ferrets are not humans, etc. The only important thing is that we really get this into people, and fortunately the NIH continues to fund us in terms of and BARDA as well. This is a joint collaboration by NIH and BARDA in terms of funding this, and we hope that we will be able to get into people in the first quarter of 2015, and also the Gates Foundation has picked up on our project, and we will doing with them a quite different kind of immunization where we prime with a live influenza virus and then come with a killed, whereas the NIH BARDA is both killed influenza viruses in terms of in inducing a cross-protective stalk antibody response. So let me end on this positive note and just ask that there will be some reason and rhyme behind these rules and regulations, and that we have a very difficult situation, particularly in the United States, where we have a declining support in terms of research and the kind of government actions which are cracking down on our, I think, legitimate research, I think are not very healthy and helpful in the long run. Thank you very much.